Zendaya 3.3 enhances the capabilities of creating and using custom mappings between SysML and Doors Next Generation by adding relationship mapping to the toolbox. In this video, we will look closely at a two-part mapping from Doors to MagicDraw, including multiple artifact and link types. The conceptual scheme for Doors NG as supported by Zendaya includes both artifact types, such as requirement and feature, and link types, such as parent of and satisfies. It is very important to remember that with Doors, both artifact and link types are project-specific. Custom mappings developed to work for one Doors NG project may not work correctly for another. How do we know what types are available for a specific project? An easy way is to go directly to Doors NG in its web browser. Here the project is Sandbox. If we right-click one of the folders in the project and select Create Artifact, we can find an artifact type pull-down list with the names of all those available for this project. This includes requirement, feature, and many others. If we choose a specific artifact within this project, system requirement in this case, we can see a links section on the lower right. Expand it and click on the Add Link to Artifact icon, and the list that appears shows all the available link types. Now let's look at the Doors elements we want to transform. In the Zendaya Dashboard Connection Manager, we have opened one of our Doors repositories on the right, and we will expand the Sandbox project. The hierarchies we want to transform are in the Relationships folder. System requirement, as expanded here, constrains another more generic requirement and is parent of two child requirements for power and mass. The power requirement is parent of two more requirements, and the mass requirement constrains another more generic version. In total, we have 7 requirements and 2 link types, parent of and constrains. We will come back to this model later to add some elements that satisfy these requirements. As always with custom mappings, we start by making sure that the artifact and relation types for both sides of the mapping, SysML and Doors NG in this case, are recognized. Under the Doors NG heading of model types, we see several we have already set up. If we select Requirement Sandbox, we see that the type is requirement, but we have appended Sandbox to the name and description. This is because, as we said at the beginning, artifact types are project-specific. When we add a new artifact type to the list, we start by choosing the repository, then the project, and then retrieving the available artifact types. If we selected a requirement in the Unmanned Aerial Vehicle project, we would be smart to append UAV to the name so that there is no confusion later. A similar precaution is worthwhile with relation types. The Doors UAV project, for example, doesn't recognize the constrains relation type, so we wouldn't want to apply a mapping with constrains when pushing a SysML model structure into that project. Creating SysML artifact and relation types is treated in video 1.8. Now let's look at the custom mapping named Requirement to Requirement Sandbox with relationships. The source or SysML artifact type is requirement, and the target or Doors type is Requirement Sandbox. The mapping name includes that sandbox designator, so users recognize not to apply it to other projects. We want children, recursive, since our sample structure has 3 levels of requirements, and we want to transform all the way down. We include attributes. The attribute mapping uses some attributes from the generic SysML requirement stereotype and some from a special Doors requirement stereotype to be used in the mapping. The target attributes belong to the Requirement Sandbox Doors artifact type. We also include relations. We want parent of and doors to map to the SysML containment relationship, and constrains and doors to map to refines in SysML. Note that all these relation types had to appear in the model type lists before they could be used in creating mappings. Now, finally, we are able to perform the model transform. On the Settings tab, we make sure the Use Mappings checkbox is checked. On the Connection Manager tab, we drag the top-level requirement from the doors model to a package in SysML. Now Syndea asks us to select a mapping out of the 3 available. The requirement sandbox name shows that this mapping is appropriate for a model from the Sandbox project. The others without that designation might not be. In this demonstration, we have already completed the model transform. If we go to Magic Draw and drag the newly created elements and relationships into a diagram, they look like this. Even though we dragged over only the system requirement, Syndea also brought over the relationships included in the mapping and the elements at the downstream end of those relationships, recursively. This includes the 5 requirements in the main hierarchy, and the 2 generic requirements that were constrained in doors, but are now refined in SysML. There is a second part to the model transform. Back in the doors model, there are 3 elements defined as features that satisfy some of the requirements. System is parent of instrumentation and power subsystems and satisfies the system requirement. The power subsystem feature satisfies power requirement. We want to bring over these artifacts and relations into SysML as well. We have created a second mapping to do this. Back in the Mappings tab, we look at the Block Feature Sandbox mapping. Note that this mapping is also specific to the Doors Sandbox project. We want to bring over all levels of blocks recursively, but we'll skip attributes in this case. We do need to map relations, but in this case, the Doors parent of relation maps to SysML part property rather than containment. Again, we select a mapping when we do the model transform, although there's only one choice this time. Back in SysML, we drag the new blocks into the diagram and display all paths to show that the satisfied dependencies have been carried over into SysML. Note also that these point to requirements that are already in the SysML model from the previous model transform. Rather than generate new elements at the end of the satisfy relations, Syndea recognized that those elements already existed and were connected back to the original doors elements. Creating custom mappings is not a trivial task, and each integrated tool has its idiosyncrasies. Syndea is set up so that a working mapping can be distributed to other users in a syndea.mappings file. We recommend that only experienced users hold the special, no-cost Syndea licenses that enable them to create mappings, and that they should collect and curate mappings for their organization.